Hello everyone, welcome to Monday's session on latest in Bitcoin tech. Uh, Today we'll discuss a particular news item from Optech newsletter number 376. This is called as the at least the author calls it as Bitcoin secure signing layer or BSSL. um, it's a it is claimed to be a vaulting system that is devoid of any requirements for a new opcode, because whatever vaulting mechanisms that have been proposed so far um, are do require some sort of a new opcode to be introduced, because these vaulting mechanisms require one to like introspect into the transaction itself. But this mechanism proposed is sort of a roundabout way, and but doesn't require any new opcode, so no sub forks are needed. It can be uh, completely enforced using scripts housed in taproots, tap leaves. So we'll go over the basic mechanism and try to understand the different parts involved in it. It of course it makes some assumptions about the custodians and all. So those assumptions do still do remain. It's not like a foolproof, cryptographically foolproof vaulting system. It involves custodians, and assumptions about the custodians also go hand in hand with this. So the basic protocol is something like this. Um, so you typically have this vault is a tap script with different spending conditions, and you put your coins that you want to vault into this vault first. And these are all the three different spending conditions that you can use to spend from this vault. So this assumes that you have created these spending conditions and locked your coins into this script, into this taproot script. So now you have three different paths to spend, and there is multiple keys involved. And here is a glossary of the keys, and we'll see one by one. So the first key called as A is the user's key that the user controls, uh, like has immediate access to it, most likely a hot wallet. And then the same keys copy is kept at a separate location to introduce a redundancy. And then the user has another key called as B. Uh, that's the user's second key, and this is also like separate, kept separate from A, geographically or physically. Then a copy of this B is held with a custodian. And finally there is another custodian C, so he also has a key. So like there are two custodians, and you will have to find two more places to keep your keys A1 and B. So this is the basic key setup that goes into this vault. So there are three paths of spending. One is the regular path. The second one is the fallback path, and third one is the custodian recovery path. So in the regular path, the user can spend either with his A key A or a copy of this key A1. Both the same, except that they are geographically separate. So if he loses access to A at one geography, he might move to another geography to recover this key A1 from that geography. So so both the keys are in fact in fact the same. So it's A or A1, and followed by an and AND operation with the cosigners or custodian's key. So in normal path, you can like spend using either of your keys and along with the custodian cosigning it. And to this there will be a 2 to 15 days delay. You can configure it when you make this particular spend, what should be the delay. And this is the regular user path spend. And the second one is the fallback path, where the user can spend with A and B. So that means A or A1 and B. So this the importance of this path is that this path doesn't require a custodian. This is to like address the issue of custodians going dark, or custodians are not sticking to their commitments. So this path is like completely controlled by the user with his own keys, except that there is a delay of there is a absolute delay of 1 year that is pre-programmed into this pending path. Then finally, the third spending path is the recovery path, in which the in which the user can spend with his second key, and the copy of B1 held with the custodian. So this is another custodian. So the user can, if he has lost A and A1, then he can like use his second key, and along with the custodian's help, he can spend he can spend this, but after a 3-year delay. So this is called as the final recovery path. This is to address the case where the user loses all his keys. So just the two custodians can help recover the funds for the user. So this is a basic setup. We'll sort of look into each and every parts, and what are the implications of the time delays and stuff like that. So if there are any questions about about this basic outlay, I'll wait for a few seconds.
Hi, Bala. I had one
Yeah,
question. Suppose that 3 year has expired and they want to ex like they want to recreate this session like scenario. Like after 1 year,
yeah,
this key will be activated, and after 2 years, particular keys will be will be available. Then they have to
yeah.
create a new transaction, or like existing system can be they can be it can
So
work.
if this is called that is what you're asking is called as chained walls. So what happens is that after in either of these two path, user fallback path or custodian recovery path, they can move these funds into a vault with a similar structure. So they can have the scripts of the same structure, except change the keys. So because these keys are lost and all, so they can change the keys and put the funds back into a similar kind of a structure. So you can like perpetuate it. So this is a basic idea that has been sketched by the author. Of course, when you construct, you can change all these delays based on your own requirements.
So my question, Bala, was not that if some keys are lost. My question was
Okay.
none of the keys is lost, but three
Okay.
year has expired, and only one key can now sign the transaction, like the C key. But the
Okay.
people who are operating this, they want to extend that for another 3 years. So okay,
Okay.
for that they have to create a new transaction, or
Yeah,
existing setup can be.
let's say the user, the funds are in the vault, and this two path have not been accessed at all. Now we are in the third year. Um, but if you are in the third year, you can use any of the above two paths also. Because you can't use this path before 1 year, but after 1 year you can use this path whenever you want. Similarly, you can't use this path up to 15 days, since initiation of this transaction. But after the 15th day, you can use this regular path also. If none of this path you want to use, you can like use this third path and move the funds, entire funds, into a similar vault, same sort of vault. If you want to use the same keys, you can continue using the uh, same
Yeah, so
keys.
new transaction has to be done after that time has gone.
Yeah,
The
yeah.
same
After
the
three
same set of
years, yeah,
yeah, okay,
yeah.
okay, got it.
Because if you don't move it to a new transaction, all these paths will become valid after 3 years, and you won't have the protection of this first path and the second path.
Okay, got it.
Yeah.
Thank you.
So,
Bala, uh,
yeah,
sorry, a basic question, Bala.
yeah,
Just so that I understand it. So the vault here is just an taproot multi-sig
yeah.
address,
Script.
right?
Yeah, yeah, yeah.
It's a script, and this entire mechanism
Yeah,
is
yeah,
achieved via that.
yeah.
The
Yeah, this will be in one leaf. This entire script will be in one leaf. This entire script will be in the second leaf, and this will be in the third leaf. So these are all different tap script leaves. And as time goes by, each and every one of these scripts will become available for you to spend.
Got it, got it. And they're not mutually exclusive, right? If it
Uh,
just activates a new path, kind, or
yeah, it activates after the delay is over. This path becomes active. After 3 years, if you have not used any of these things, you can use any of the three paths. So they are not mutually exclusive.
okay, got it, got it.
Yeah.
Thank you.
So the regular path is designed to be the primary mechanism for the user to keep spending from the vault. um, but the protection that exists here is just to ensure that the user the transaction doesn't go through immediately. So that's why there is a two you can configure it to be a 2 hour to 15 days, the delay you can configure it, and it will be a relative time lock. So the moment the user composes this transaction, this spending path, and broadcasts it, the clock starts, and the funds will be taken up for putting for being mined into a block only after the relative time lock that you put into this whole transaction expires. So the purpose is that you can like have an external observer watching the chain for spends from your address, and so you'll have some time to react. So if you have a minimum of 2 hours of delay, and you have some program, or you have some script watching the mempool for spends from your address, and you create an alert, and once this transaction hits the mempool, you'll get an alert, and you can if you are the one who compose the transaction and broadcast it, no problem, you just have to wait for 2 hours, and after that transaction will be like taken up for putting it in a block. But if you suspect some attack, what you can do is that immediately you can like use the fallback path, or the recovery path, so that once you suspect an attack, you can create a transaction. You'll have some time. You can create a transaction with your keys A and B, and then broadcast it, and this PSBT, this transaction will um, will be uh, will be taken up, and you won't be able to spend from this using this path. Um, then Actually, no. I was little confused. So, if your key is compromised and the custodian colludes with the attacker, then this path will obviously go through. But the only thing is that if your key is compromised, because there is a custodian, your funds are safe, and and also the custodian cannot spend unilaterally because there is an and condition involved. So both parties can mm, can prevent unilateral attacks by them. So that's the whole idea behind this spending condition. Uh, the delay is there just to make sure that um, make sure that the transactions are in order. If it is not in order, you can go ahead and create another replacement RBF the whole transaction with a different address that you want to, because there is some delay to it. And of course, this doesn't prevent any racing kind of condition where your RBF gets RBF by the attacker again. That kind of condition is not addressed by this setup. So yeah, this is not a perfect vaulting setup. It just gives you some given the assumptions that the custodian is not working with the attacker. Um, it can help you protect your funds in some scenarios. So that's the regular user path spend. Then the fallback path is a mechanism that exists to completely if you suspect a custodian has gone bad, um, suspect custodian doesn't respond, he goes blank, then you can after 1 year delay. This 1 year delay is hard coded in the vault while creating the vault itself. So after 1 year of delay, you can, as a user, you can use your two keys to spend along this path. um, uh, w- the what the implication is that it sort of gives you a natural refresh cycle and some sort of independence from the custodian. So of course there is a delay involved. So you can be free of the custodian only after the first year, and this will sort of become an exercise. So after 1 year of expiration, you have to move these funds to a vault, to a different vault. So this is a vault progression that usually happens. So this is your year zero. Now you have three paths to spend. But at year zero, you have only one path. After year one, this path one and path two becomes eligible for you, and path three is still not available. But what you do is that you move this entire transaction to the new vault after year one. So this new vault gets created. Now you have path one and path three, but this path three like relative to the time when you have started, it gets pushed to year 4. So now you are in year 1, and you will be able to spend from this vault at year 4. So this is how vaults are progressed over time. If there is no if you don't use path 1 at all, so you can use path 2 to keep refreshing the vault after the expiration of path two's time. So after 1 year expires, you can keep chaining the vault. So this is called vault progression or vault chaining. Then finally, you have this recovery path. It's sort of a last resort mechanism. So typically, when you create the vault, you will pre-sign this. transaction, and keep this PSBT ready. It'll be either it'll be your key, or the second custodian's key and the first custodian's key, and you'll sign this PSBT and keep it ready. And once 3 years, like there is no activity from the user's end, uh, there is no activity from the user end till year 3, and the custodians realize that it's their responsibility to move the funds from the vault. Then custodian 1 and custodian 2 can broadcast this PSBT and move the funds either to a new vault or out of the vault. So this is like the third or recovery path that has been proposed. So yeah, that's about the three parts. So yeah, if there are any questions.
Bala, see, all the three participants like A, B, C, do they have to store wallet descriptor along with their keys? Or
Yeah, yeah. This will be implemented using Miniscript and uh, on tap script, and I think they will have to store all the details.
regarding wallet descriptor, I had one question. Like, is there a
Yeah,
standard format of wallet descriptor of what data has to be stored for
yeah.
recovery of the wallets? If it is not there, then is there a SOP or standard things which we have to essentially store in wallet descriptor file?
Yeah, basically, this is the uh, format of descriptors. So if you can see here in the screen,
Yes, I can.
so yeah, this is the format. So typically, the descriptor will start with the function type, which is whether it's a taproot, P2PKH or P2WPKH. That will come first. Then followed by the derivation path for the key, and then the xpub itself at this derivation path. Then finally followed by what sort of path from this parent you are taking to derive the rest of the keys. So and finally you have the checksum. So this is the standard descriptor format. So if you if you have to uh, for a taproot in our case this will become pay to p2tr p2tr, and you'll have to specify uh, from which xpub what is a master's derivation, then the xpub from which you are going to derive the keys that you are going to use here, all the keys. So all these things you have to save and communicate between the users.
Uh, Bala, in that second part, derivation path of
Mm,
this key, that
yeah.
what is this D34 DB33F? It is a like a master signature, master finger
Yeah,
or something.
that is a fingerprint. Yeah, that is a master key's fingerprint, and followed by the master derivation path. So this is fingerprint followed by 44 hardened path 44 followed by 0 and 0. So this will become the base, and this will be the xpub that corresponds to this path, and from here starts your derivation. So if you add all these things up, it will be like 44 harden 44 harden 0 harden 0 followed by 1, and then all your keys 1 2 3 4 5 6 till the end of it. So that here is where it'll keep changing this number to get the keys.
Okay, Bala. Okay, thank you.
Yeah,
Bala, just to add to that, so
yeah.
is it like a single wallet? Is it a single wallet description file that is used to derive both A, B keys that the user will store in a different location? And
Um, Not necessarily. Uh, I the details of the implementation is not out yet, so it's just a basic algorithm, like basic scheme description. Um, it typically the custodian will have his own private key. The user will have his two different private keys. The setup now is that these are all individual keys, but of course, he might have the user might have use the same master key and have multiple private keys from the master derived, and he might have altered different things. So it is up to the user to keep a track of what keys he has used to create it, and what keys he will be requiring to sign it, and the same goes for the custodian. So all these or and and conditions are realized using PSBTs. So the user just composes the transaction, uses his own keys to sign the transaction, and sends the PSBT to the custodian. The custodian, what he'll do is that he will use his own key to sign to countersign the PSBT and complete the transaction and send it back. Either he will broadcast or the user will broadcast. So yeah. To answer your question, the descriptors have to be maintained by each of the keys custodians.
got it. Interesting. Got it.
Yeah.
And it depends on so this configurable delay. So it
Yeah.
would depend on the uh, on for example, let's say I send 1 Bitcoin to this vault, and
Yeah.
and to spend this configurable delay of 1 year, and so on and so forth, corresponding thing will be relevant. Now suppose some more Bitcoins come into this vault uh,
Mm-mm.
from
No,
from when.
that that is not possible because um, this is one single UTXO in which you are going to lock your coins. Let's say the one BTC, you create a UTXO, and like you create this UTXO with that one BTC with all the spending conditions. And once you you use any of this path, this UTXO does not exist. This UTXO gets spent, and you'll have to move to a new UTXO. And that new UTXO, you can replicate the same vault, or it can be something else completely.
Okay, per UTXO basis. Got it.
Yeah, because we can't think of it as an account system where like we can keep filling this in, because Bitcoin doesn't work that way, and UTXOs are single use and they get extinguished once you spend them.
Right. So I was thinking on the lines of script-sig addresses, but perhaps it's like you said, UTXO based is what.
Yeah.
Got it. Okay. This is sort of still out there in the community that they're trying to experiment with, right? None of the.
Yeah, this the an author named uh, Elihan has proposed it, but there are like questions out there in the Delving Bitcoin forum, and he's trying to defend or justify this construction. Uh, let's see. Yeah, I think more. There are some assumptions with respect to the custodians. So here, after 3 years. There is no way to prevent custodian B1 and C colluding to move the funds out of the user. If the user just forgets it and 3 years has elapsed, C and B1 can collude and move this fund out of the control of the user. So that remains to be addressed. And here, if the in the regular path also, if the custodian colludes with an attacker, um, like there is no way for for the user to prevent this transaction from being broadcast or mined, because he can only use his two keys after 1 year. So within 1 year, if this custodian, if somebody attacks A1 and somebody attacks the user, gets hold of either A or A1 and goes to the custodian, they can collude with the custodian and move the funds away from the user. He can't do much because he can only use his keys only if after 1 year. So yeah,
Mm,
so
mm.
these two issues remains like to be addressed.
Okay, okay, interesting.
Yeah, like now, people are like coming up with these vaulting ideas because Miniscript is a little bit mature and people are learning to use Miniscript, and they are using that with the help of Miniscript. People are writing these kinds of logics, because without Miniscript, you have to like arrange each and every of the script into a tap leaf. That's little hard, and the chances of creating a mistake are very high. So because of Miniscript, people are like able to do it, but still there are like you have to put this entire vaulting script into a formal testing mechanism, so that there are no undefined, you have to like verify there are no undefined states, and like there are no there are no colluding possibilities and all those things.
Okay, okay, interesting. Interesting. Bala, on similar lines, so when they say copy of A and copy of B, they're not like a replica, right?
Yeah, it's the same key. The whole idea is that you have your key at two locations. So if you lose access to your key at this location, you can go and retrieve the same key at a different location. And similarly, B is you have your second key, but you also have given the second key to a custodian. So that's the idea behind this copy. So it's the same key, essentially the same key.
Okay, okay, right, right. So, okay. So after 3 years, the risk is the higher with custodian because he will
Yeah,
have your key. That is one of the use cases that one of the vectors that.
yeah, yeah. If the two custodians collude, then there is no way for you to stop them from moving the funds.
Okay. Cosigner also is considered as one of the
Yeah,
custodians.
it's both are custodians. This C is called as cosigner because in your regular path, you definitely need this need him to sign your transaction. B1 is called as a custodian because only after 3 years and only if you lose your key, you will need B1. If you have your own key, and then there is no problem, you can just call up C and ask him to co-sign the transaction and move your funds out. So
Cool.
B1 is required only in the worst case. After 3 years, you have lost all your keys. You have lost A, you have lost A1, and you have also lost B. Then you have to knock on B1 to sign the transaction.
Got it. Got it. So these three parts ensures that if at least if one actor is not available, somehow it will go
Yeah,
through.
yeah. It ensures that at least if the custodian or co-signer is integral, or he doesn't collude, then theft of funds is not possible. And this also gives you peace of mind that even if you lose all your keys, there is another two custodians out there who can like help you in recovering your funds.
Got it. Got it. Interesting. I think these things are like a good use case for estate planning
Yeah,
and
yeah, yeah.
yeah.
Yeah, the user, the creator, he's underscoring the fact that um, um, you even if you lose all your keys, there is some way to spend out of spend to recover your funds. So this sort of gives you a peace of mind. Only you have to ensure that the custodians are integral. So if you're
Mm,
sure about your custodians, then you can like have peace of mind.
mm. Got it.
Yeah, these are like for absolutely the people are putting this up for estate planning, and people are spinning up companies based on these scripts.
Or already
So
there are a few estate planning custodians
yeah,
whether CASA,
yeah,
those
man. I
things.
think Casa and Swan they are there, but they all use simple multisigs, so they don't
Hmm.
do these kinds of complex constructions. So well, they are simple multiscript. They use simple multiscripts, two of three at the max, and yeah, but their reliance is more on legislation, jurisdiction, that kind of stuff.
Hmm. Right, right. Interesting. I know a lot of people just buy ETFs with the worry that because of the estate planning.
Yeah,
If these kind of solutions kind of, are well available, well set up, and are
yeah,
foolproof, I think that's a positive thing.
yeah, yeah, true. Like you can miniscript is interesting, like you can explore miniscript, and you can construct these kinds of different vaulting mechanisms using miniscripts. And if you can like convince people to buy your service, yeah, that's a viable business plan. It's just that you need to prove them that your setup or the script is solid. It doesn't lead you to unspendable path, unspendable conditions, and also ensure that these custodian integrity of these custodians, then it's a solid offering.
Mhm. Got it.
Ala, I had one
Interesting.
question. Suppose we
Yeah,
have set up this mini scripts and it is under one UTXO.
yeah.
So how someone test that this is working or not? Because if we test it by spending from UTXO, then it essentially created a new UTXO and we have to test it again. So how do we test that is working or not? It should not happen that
Mm,
after 2 years we try to spend it and it is not working somehow. I don't
yeah.
know. Like, huh.
So, first things first, there are like there is something called as form analysis that is used to test these scripts. It doesn't involve any UTXO or Bitcoin transaction. It just purely takes the mathematical construct of these OR and AND conditions, and it can prove to you mathematically that this construction of script doesn't lead to let's say unspendable conditions, or it doesn't lead to loss of funds. So you can test for whatever risks that you want it to test against. So that is one way. And the second way is of course to create a testnet transaction with compressed timelines, so that you should not like wait for 1 year. If the script is good for 1 day, it will also be good for 1 year, because the time delays are enforced by the protocol itself. It's not enforced by the script. So that's another way to test it. And
Okay, okay,
typically you should have a it's not just one time thing. So as the user keeps spending, your system has to like pick up the users. Let's say the user has 1 BTC and he has used this regular path and he has spent zero point 0.5, but the user wants the remaining point, the change to go back into a similar vault like construction. Then your wallet, typically it has to be in a wallet. So your wallet has to put the change back into a similar sort of construction. So it has to be a wallet, either the form of it, whether it's a desktop or mobile, or a web application where the user calls up the custodian and does these things. So it has, you have to figure out a mechanism to implement this.
okay, man.
Yeah. So yeah, that's where putting together um, a wallet or business out of it is, first you have to like test and prove the integrity of this construction, whatever might be the construction, not just this, even whatever construction that you can come up with. First thing is to prove the integrity. Then you have to create a wallet that perpetually moves your funds into different vaults. So, and of course, you have to take care of the custodians and who will be the custodians that have it, and you have to prove to the user that these two custodians have zero chance of colluding. So, yeah, that kind of setup.
Bala, this part of wallet progression, what
Yeah.
is the significance of it? I could not totally wrap my head around this.
So basically, see, this is one single UTXO that has different spending conditions. So let's say you have one UTX, one BTC here in this, and you have locked it in this way, and you want it in this way. So now the user makes a spend out of the one BTC. So he picks up either regular path or full path or whatever path, and zero point 0.5 BTC goes away to whoever he wants to send it. The remaining change, now uh, he wants, or the user wants the change to also be logged in with the similar setup. So for that, you have to move the change not into a simple P2 P2WP P2 pay to witness public key hash script, but into a script with this construction. So your wallet should receive the change in this script, not in a simple. If you go to your regular wallet, the change will be received in a regular Segwit wallet. The change will be received in a pay to pay to witness public key hash script. So that shouldn't happen for your wallet. The change should be received into another vaulting script which has the same construction. So that is what is called as vault progression. So you move funds, either the whole fund or the remaining change of it, you keep moving into vaults.
Got it. Makes sense. Makes sense. And you sort of delay also the relative delay you are supposed to negate and construct that one, I believe,
No,
right?
it is. You don't have to do anything. It's the same construction. Say, let's say, for example, you have one BTC here, and the user wants to spend, and he composes this transaction, broadcasts it, and he puts a 2 hour relative time lock. And after 2 hours, the funds go through. And out of this, what comes out is zero point 0.5 to the vendor or whoever he wants to pay, and the remaining zero point 0.5 should get into a script of the same construction. So you should have a regular user path, and you should have all these three paths. So for that, he needs to have the script ready, the same script ready with an address and all, and so that he can spend the change into that address.
Right. Indeed, indeed. But
Yeah.
what I was wondering is on the delay. The delay would be reset, right? If it is relative.
Yeah. You can all these things will be reset. So this will become 1 year from when you start this. Uh, so this is also like configurable. Like you can write the script in such a way that because this is a absolute no no yeah, this thing will get reset. So you wait for 1 year, and you move this to another same sort of script. The new UTXO will again get a fresh lease of 1 year delay and 3 year delay.
Got it.
Yeah.
Bala, I had one question regarding time locks. Is there a way or the scripts allow that if like A or B are not able to spend, but it has moved to like third scenario where
Okay.
C only can able to spend, but the spending address can be predefined. It can be A
Yeah.
or B's address, and only that address he can spend, not any other address. So we can reduce the risk of like custodian taking the funds.
Yeah,
Can
that is the ideal case where when you are creating the vault itself, you can create the PSBT for this transaction also. You can use your own key, and you can ask the custodian C to co-sign the transaction such that this goes back to your address. So you can have that transaction signed and ready, and that transaction will be picked up by the mempool after 3 years, and it is a valid transaction and it can be mined. But if you don't have that PSBT already signed and broadcast, after 3 years, there is a chance that C and B1 can collude to create a transaction that doesn't send the fund back to you but to their own addresses.
okay, well, thank you.
Yeah. So yeah, that's all I had for today.